of number 1, it is x upon x plus 1 bracket raised to 4. Number 2, y equal to x log of x minus 1 upon x plus 1. This is 1, and number 2 is y equal to x minus 1 bracket raised to n. Prove that y plus y1 plus y2 upon 2 factorial plus y3 upon 3 factorial plus etc. plus yn upon n factorial equal to x raised to n. Now out of this, when we solve the first one, it is y equal to x upon x plus 1 bracket raised to 4. We will first of all find out y1. So it is v du. So x plus 1 bracket raised to 4 into 1 minus x into 4 times x plus 1 bracket cube into 1 upon x plus 1 bracket raised to 8. And so this will result in 1 upon x plus 1 bracket raised to 4 minus, it will be 4x upon x plus 1 bracket raised to 5. This is solvable because it is 1 upon ax plus b bracket raised to m. This is still not solvable. Or one way is this. Second way, we can always go for x plus 1 minus 1 upon x plus 1 bracket raised to 4, which will straight away result in 1 upon x plus 1 bracket cube minus 1 upon x plus 1 bracket raised to 4. So we need not go for this. We will simply rewrite y and use formula for 1 upon ax plus b raised to m. For the second one, as y is given as x log of x minus 1 upon x plus 1, we can write it as x log of x minus 1 minus x log of x plus 1. And then y1 will come out to be, y1 will be x into 1 upon x minus 1 plus 1 into log of x minus 1 minus x upon x plus 1, and it will be minus log of x plus 1, and you will have to apply the formula. Here you will have to adjust again x minus 1 plus 1. This will be x plus 1 minus 1. We have formula for log of ax plus b. We have formula for log of ax plus b. Okay, so this becomes again straightforward. We can't do anything initially. It has to be differentiated once and to be done. And here y1 will come out to be n into x minus 1 raised to n, y2 x minus 1, n into n minus 1 x raised to x minus 1 raised to n minus 2. If you just substitute, it is a binomial. Okay. Or you can always consider it as x 1 plus x minus 1 bracket raised to n. If you expand by binomial, you will get these terms. That factorial is missing, that he has added. So again it can be proved very easily, straightforward. Okay, do this. Here again there is an adjustment, as I have said. It will be x minus 1 plus 1 upon x minus 1, and this will be x plus 1 minus 1 upon x plus 1. Of course, one constant will result, that doesn't have any effect, right? Karo. We'll start with the next one. Leibniz theorem. Now this particular theorem will talk about the extension of the formula for the product of the two functions. We have y is equal to u into v. Now if we differentiate, we will get y1 is equal to u v1 plus u1 v. With this notation now. Normally we say it is u dv by dx plus v du by dx, right? I am not changing the positions, I am keeping them as it is. What will be y2? This will be differentiated, so it is u into v2 plus u1 v1. First is differentiated. When second is differentiated, it will be plus u1 v1 plus u2 v. Right? So it comes out to be u v2 plus 2 u1 v1 plus u2 v. If we go for finding y3, it will be u v3 plus u1 v2. That is the differentiation of the first one, plus 2 into bracket u1 v2 plus u2 v1 plus it will be u2 v1 plus u3 v. Will come out to be u v3 plus this and this, so 3 times u1 v2 plus 3 times u2 v1 plus u3 v, and which gives us the idea that these are the coefficients of square, these are coefficients of cube. So when we go for y4, we can write it directly, it is u v4 plus 4 times u1 v3 plus 6 times u2 v2 plus 4 times u3 v1 plus what will be the last one, u4 v. And we can always have yn. It will be u into vn plus what should I write, nc1 u1 vn minus 1 plus nc2 u2 vn minus 2 plus etc. plus ncn minus 1. It will be u n minus 1 v1 plus it will be un v. This is the Leibniz theorem. Okay, so what he has done is he has differentiated successively. He has now taken y equal to u into v and found the nth derivative of it, which is generalized, which is just the coefficients are binomial expansion. You will have to start with the function and nth derivative of v, and then first derivative and n minus 1. Like that you will have to keep on differentiating first function and in a way integrating second. Start with the nth derivative. There, this particular formula can also be written other way around, which is just the same, un into v plus nc1 un minus 1 v plus nc2 un minus 2 v2 plus etc. plus nc n minus 1. It will be u1 Vn minus 1 plus u Vn. Just the same. Okay, make a note. The next problems are based on this, where we will be given the product of the functions and we are required to find nth derivative. Right? So the set of problems is now it is first one, find nth derivative. First one is x cube cos x. Second one is e raised to x into 2x plus 3 bracket cube. Third one is e raised to ax into bracket a square x square minus 2n ax plus n into n plus 1. And fourth one is x square e raised to 3x cos of 4x. Now it is interesting that which formula you are using and how to proceed. You tell me which formula you are going to use for yn. Is it u into vn plus etc. or un into v? Because accordingly our u and v functions will be decided. U vn, this is what we will use. Now see, x cube, its nth derivative is 0, right? So we should start from x cube and go on differentiating it. There will be only 3 terms. If he is asking us to find yn, then can we ask examiner or paper setter what is n? No. I will tell you one joke. It happens like that. When it is finding yn, it is general n. It might fail, it might fail. What do we do in that case? Right? त्यामुळे n वरती अवलंबून असणार हे सगळ्याच गोष्टीत आहे. तर त्याला आपण काय करणार? What you expect me to do? I can't help. But the policy over here is this will vanish after 3. Right? So we will choose u as x cube and v as cos x. This is very first step that we write. Okay, there is no confusion into this. We start with u as x cube and we write vn. What is nth derivative of cos x? Nth derivative of cos x is cos x plus n pi by 2. So far so good. Then we go for u1, which is 3x square. Vn minus 1, it will be cos of x plus n minus 1 pi by 2. Then u2 is 6x. Vn minus 2 is cos of x plus n minus 2 pi by 2. u3 is 6. Vn minus 3 is cos of x plus n minus 3 pi by 2. And u4 is 0. So it doesn't matter what is Vn minus 4. And when we write the formula now, it will be yn is equal to uvn plus n into u1 vn minus 1 plus n into n minus 1 upon 2 factorial u2 vn minus 2 plus n into n minus 1 into n minus 2 upon 3 factorial u3 into vn minus 3 plus n into n minus 1 into n minus 2 into n minus 3 upon 4 factorial u4 into vn minus 4 plus etc. I am writing the term which will be 0. just substitute and you will get the answer as cos cube x cube cos of x plus n pi by 2 plus n, rather 3n x square cos of x plus n minus 1 pi by 2. Of course, we cannot determine what is cos of x plus n pi by 2 because n is not known. So, answer will remain in these terms. Then plus it will be 6 into n into 6n into n minus 1 upon 2 factorial. So, again it will become 3 into x into cos of x plus n minus 2 pi by 2 plus 6 n minus 1 into n minus 2 upon 3 factorial cos of x plus n minus 3 pi by 2. That's it, full stop. There is nothing dot dot dot. Answer remains in this way. In the second case, what will be u? That is the only thing to be decided. The one which will vanish should be u. So, of course, this. In the third one, this one will be u. And in the fourth one, x square will be u, and we should use the formula for nth derivative of e raised to ax into sin or cos bx plus c, which will be r raised to n e raised to ax into sin or cos of bx plus c plus n theta, where theta is tan inverse b by a and r is root of a square plus b square. So, in a way, much more clerical work, no intelligence required. Only thing we require is the nth derivative formula. If we know that, we can do this. If we don't, we can't do this. And choosing it is proper. Formula is u v n. If we are starting with this, then u should vanish. Okay. If the formula is u n v, then v should vanish. Right? ज्याचा nth derivative येतोय तो आपल्याला घ्यायचा vn. Right? Do them. Or should I do them? It is just you should know the formula, that's it. Are you able to differentiate 2x plus 3 bracket cube? Yes. First derivative is 3 into 2x plus 3 bracket square into 2. Second derivative will be 3 into 2, 6 into 2x plus 3 into 2 into 2. Original 2 and new 2. And then finally. Here he has purposely given this n and n plus 1 so that some cancellations will take place. Here also, after this, there will be one step where you will cancel this 3 factorial with 6. You will cancel this 2 with 6 and write it as 3. That's the only thing you can do. Right? इथे तर काय cancel होतच नाही. Right? Now these type of problems can be asked in online exam, because these you can simply do orally. You can look at the answer also and you will come to know which is the correct one. But the next type into this, which is application of it, if you recall, on the very first day we started with something which was involving y1, y2, etc. on the successive differentiation, when there was nothing like nth derivative. But now the question will go like this: if y is equal to sin inverse x, prove that 1 minus x square yn plus 2 minus 2n plus 1 into x yn plus 1 minus n square yn is equal to 0. Now these type of problems that we have, we will have to observe the answer as what he is doing. It is n is involved, this is nth derivative, next derivative and next derivative. So we should think in this manner that I will have to go for the relation which is between y2, y1 and y. That is what we started on the very first day. So we start with y equal to sin inverse x, and therefore y1 comes out to be 1 upon root of 1 minus x square, right? So I can write it as root of 1 minus x square into y1 is equal to 1. I can square it. It will be 1 minus x square y1 square is equal to 0. I don't want that root, is the only thing, because when I differentiate it once again, it will be 1 minus x square into 2 y1 y2. Do you agree? 1 2 y1 y2, right? Then what will be the next term? Minus 2x into y1 square is equal to 0. So we can cancel y1. Yeah, 2 also is cancelled, so we have 1 minus x square y2 minus 2 minus x y1 equal to 0. So far so good, right? And now of this we should be taking nth derivative. Using Leibniz theorem. So this will be my u, this will be v. So the terms will go like u vn. So y2's nth derivative will be yn plus 2, right? Plus n u1 into y n minus 1, that is yn plus 1, plus n into n minus 1 upon 2 factorial into minus 2, that is u2, n minus 2 derivative, that is yn. So first term is differentiated n times using Leibniz, minus into bracket x is u, nth derivative of y1 is yn plus 1, plus n into u1 into n minus 1th derivative of y1 is yn is equal to 0, which turns out to be 1 minus x square yn plus 2 minus 2xn yn plus 1. This 2 cancels, so it will be plus, or rather minus n square minus n yn minus x yn plus 1 and minus n yn equal to 0. So it comes out to be 1 minus x square yn plus 2. If you combine this and this, it will be minus, यहाँ से x if we take common, it will be 2n and 1, 2n plus 1 yn plus 1. This is minus n square yn plus yn minus yn, so it will be minus n square yn equal to 0. Proved. So this is the part which we did last time, which we have done right at the beginning, and even in between one day we have done finding the relation between y, y1, y2, y3. We did not want x or the original thing into that with this intention that there should be only the algebraic terms involved, so that taking nth derivative will be easier for us. So it will vanish. If we have something like e raised to x and cos x as two terms, then none of them will have nth derivative as 0. So our preference will be to get the algebraic terms polynomial in x, so that it will be eventually vanishing. Got the problem? And almost all of them are prove that type, all of them. And you will have to first of all come till this level. So don't get hesitated. See, I started with saying that there should be a relation between y2, y1 and y, because after taking nth derivative I might get it. But then when I got the relation, there was no y involved into it. And can I start from here going for nth derivative? I can't. One can go for nth derivative of this also. If it turns out to be only x square y1, I could have gone for nth derivative. But because of root, I had to go for square, and the moment it becomes y1 square, I can't apply the nth derivative formula. It has to be y1 or u1, not v1 square, not u1 square. No. So I will have to get rid of that square or this root. So I first got rid of this particular root. I landed up with this, so I had to differentiate it once again. Even if you would have started from here, what you would have done, from y1 equal to 1 upon root of 1 minus x square, the next derivative y2 would have been minus 2x upon 1 minus x square bracket raised to 3 by 2. This would be the derivative. Now what will you do with this? This is of no use to us, because even if you say 1 upon root of this, it will be, you can write it as minus 2x into y1 cube.
Minus 2x into y1 upon 1 minus x square.
Okay, but even this is right. This is y1 cube also, but looking at the answer, it will be y1 upon 1 minus x square, and you will get this. But we can very well make a mistake of putting it as y1 cube, and through y1 cube now there will be a trouble, because we don't want any of the derivatives in the powers. It should be the first order, or rather first degree. Order of differentiation can be anything, but the degree should be 1. This is degree 2. We want first degree only. So you can proceed in any way, that doesn't matter. Remember the rules that we should have only the terms of y, y1, y2, y3. It can be anything, but no powers, and coefficients should be preferably polynomials. Then only nth derivative will result in the terms getting vanished. Otherwise there will be n plus 1 terms every time. That's not feasible. Okay, do this. I will give you 1 or 2. Let us see how you try them. Y equal to sine inverse x bracket square. Prove that 1 minus x square yn plus 2 minus 2n plus 1 x yn plus 1 minus n square yn equal to 0. Here is one more interesting case. He is going with sine inverse square, and result comes out to be the same, nth derivative. Y equal to e raised to tan inverse x. Prove that 1 plus x square y2 plus 2x minus 1 y1 equal to 0, and 1 plus x square yn plus 2 plus 2 into n plus 1. Okay, I will write it later only. It's a long expression. You do this, and then we will do this. Y equal to sine inverse x bracket square, and it was to be proved as the same previous expression. The next problem is y equal to e raised to tan inverse x. Prove that 1 plus x square y2 plus 2x minus 1 y1 equal to 0, and 1 plus x square yn plus 2 plus 2 into n plus 1 x minus 1 yn plus 1 plus n into n plus 1 yn equal to 0. Fourth, y equal to cos of m log x. Show that x square yn plus 2 plus 2n plus 1 x yn plus 1 plus m square plus n square yn equal to 0. Fifth, y equal to x plus root of x square minus 1 bracket raised to m. Prove that x square minus 1 yn plus 2 plus 2n plus 1 x yn plus 1 plus n square minus m square yn equal to 0. Out of that, the first one we have already seen, which is not a big deal, because we will start with, as y is given as sin inverse x bracket square, y1 will be 2 into sin inverse x into derivative of sin inverse is 1 upon 1 minus x square, which one can write it as root of 1 minus x square into y1 is equal to 2 sin inverse x. Squaring it will be 1 minus x square y1 square equal to 4 times sin inverse x square, which is nothing but 4y. And then when we differentiate it once again, it becomes 1 minus x square. Y1 square is differentiated as 2y1 y2 plus minus 2x into y1 square equal to differentiation of right hand side will be 4 times y1, and we cancel y1 throughout and even 2, so it becomes 1 minus x square y2 minus x y1, and it comes out to be 2, and then we go for finding the nth derivative. So in the previous problem this was 0, now here it is 2. That's the only difference. In the seed first, this was second problem. In the third problem we have y equal to e raised to tan inverse x. So when you differentiate it once, it is e raised to, the derivative will be e raised to, into differentiation of tan inverse x is 1 upon 1 plus x square, which gives us 1 plus x square y1 is equal to y. Right? But he doesn't want us to prove that. We will have to differentiate it once again. So it will be 1 plus x square y2 plus 2x y1 equal to y1, and his thing is proved. And then differentiate it n times. Okay, that is again 1 plus x square as u and y2 as v. In the fourth problem, it is y equal to cos of m log x. Now when we differentiate it, y1 will be minus sine of m log x into m upon x, right? So we can write it as x y1 equal to minus m sine of m log x. We differentiate it again, so it will be x y2 plus 1 into y1 equal to minus m, derivative of sine is cos of m log x into m upon x. And so when you multiply by x, you will get x square y2 plus x y1 equal to minus m square cos of m log x, and cos of m log x is y, so it is minus m square y. So we come till that point, and now we are required to differentiate it again by n times, right? Karo. Then I will explain this fifth one. These are the initial stages. I have brought you to the point from where you are required to differentiate it n times using Leibniz formula. Nikita, tell me what you have done after this. You are supposed to take nth derivative of this. It is u into v, uvn we said. So it will be 1 minus x square as it is, yn plus 2 minus n
y plus 1 minus 2n.
What happened to this derivative of this y1 u1? What is the formula? It is uyn plus n into u1 yn minus 1. So where is u1? Tell me the terms again. It is nth derivative of this is what is the very first term? uvn. So how will you differentiate it n times, the first one?
Sir, u will remain as it is.
So what is u?
1 minus x.
So tell me it like that.
So 1 minus x square y2.
Who is going to take nth derivative of y2?
Yn.
Nth derivative of y2 is yn. Then you have taken down the problems, right? Tell me, Aniket. I am going to, from here I am picking up, take nth derivative using Leibniz theorem. Tell me.
1 minus x square
1 minus x square into
yn minus 1.
what is nth derivative of y? What is nth derivative of y? What is first derivative of y?
y1.
y1. Second derivative?
y2.
Third derivative?
y3.
What is nth derivative?
yn.
yn. What is nth derivative of y1?
yn plus 1.
Then what is nth derivative of y2?
yn plus 2.
So where did you get yn minus 1 from? yn plus 2. What is the formula? It is uvn plus n into u1 vn minus 1. So what is the next term? plus n into, what is u1?
2, sir, 2x.
What is derivative of 1 minus x square?
1 minus x square, sir.
What is derivative of 1 minus x square? अरे बोल, काय घाबरतो काय? अजून मी हात उचलत नाहीये. हा बोल. अरे what is derivative of 1 minus x square?
Minus 2x.
Ha, so n into u1, that is minus 2x. What is n minus 1th derivative of y2?
N minus 1.
N minus 1th derivative of y2.
N minus 1. Y n minus 1.
What is n minus 1th derivative of y1? Y is yn minus 1. What is n minus 1th derivative of y1? This is nth derivative, right? So it was, nth derivative was yn plus 1. So we are talking about what? For y1 we want n minus 1th derivative. So what it will be?
Yn plus 1.
Plus, what is the next term?
Sir, n into n minus 1
N into n minus 1
upon 2 factorial.
upon 2 factorial.
Minus 2x the derivative.
Minus 2x derivative is minus 2.
Yn.
Yn. That is first one. Now minus into bracket. What is u?
1 minus x square.
अरे तो जाता है, झालं ना आपला. What is
X.
x? So what is first term? X into u into vn. What is v?
N plus y.
What is v?
y1.
y1. What is nth derivative of y1?
Vn. Yn plus 1.
Yn plus 1. Plus next term.
Nth derivative of x is 1.
अरे कुठे आहे nth derivative of x? What is next term? It is n u1 vn minus 1. So what will be the next term?
Sir, n
N
u1 is
u1 is
x derivative
1.
1. Vn minus 1 is yn plus 2. Yn.
I was knowing that you are going to make, and then I suppose now you can take the things common and it will be proved. Right. Correct करा निकिता, अनिकेत. हा, कोण रे पुढचा आपल्याला सापडणार आहे ते कोणतरी. ऋषी. We pick up from here. We have already 1 plus x square into y2 plus 2x y1, or you can write it as 2x minus 1 y1 equal to 0. Take nth derivative. What is u? 1 plus x square into nth derivative of y2. Yn plus 2. What is the second term? So this is u vn plus n into 2x into yn plus 1. Next term plus n into n minus 1 upon 2 factorial into 2 into yn plus. Now for the second term, what is un? What is u? 2x minus 1, and v is y1. So what is first term? u vn. So it will be 2x minus 1 into yn plus 1 plus n into u1 2 into yn. Right? Good. Now for the fourth one, Nikita, we have x square y2 plus x y1 plus m square y equal to 0. Take nth derivative term by term. What in the first term? What is u? What is u? अगं माझी आई इथं यू कोण आहे सांग ना. What is u? There is a product of two terms, u into v, right? And we are supposed to take nth derivative. So what is u? X square. What is the formula saying? First term is u into what is the formula? Nth derivative of u into v is u vn plus n u1 vn minus 1 plus n into n minus 1 upon 2 factorial u2 vn minus 2 plus n into n minus 1 into n minus 2 upon 3 factorial u2 vn minus 2 and so on. Right? Aditya Vartak, Sanga. Differentiate it n times. First term. What is u? X square into yn plus 2 plus second term plus n 2x yn plus 1 plus n into n minus 1 upon 2 factorial into 2 into yn plus second term. What is u? X. Differentiate. X into yn plus 1 plus Aditya Vartak सांगेल. Next n what is derivative of x? 1 into yn plus what is u? 1. So u is not there. So what is the term now? Y. What should I write? M square y. What is nth derivative of y? Y. We are taking nth derivative from here, right? So m square is constant, nth derivative of y is yn equal to 0. So I suppose this 2 cancels, this minus nyn will cancel with this will remain n square plus m square yn. Right. Now I have to follow this policy, right? Instead of engineering, you are planning to become the clerks. And without thinking, you are just taking down the things. Nikita. No, not Nikita. We'll go for somebody else. Shaunak. Fifth problem we haven't done. Or, okay, we continue with this. This we did, no? Right, yeah, Shaunak, this one. We haven't done anything for this problem, right? So now Shaunak will tell us how to proceed. What we have is y equal to x plus root of x square minus 1 bracket raised to m. करतो नाही सांगायचं, नाही लिहिलंच तरी चालेल, बोल, मी लिहितो. We will have to find a relation between y, y1, y2 and then go for nth derivative, right? So first step is to differentiate. y1 equal to m x plus root of x square minus 1 raised to m minus 1 into 1 plus 1 upon 2 root of x square minus 1 into 2x. So far so good. 2 cancels. So it will be m into x plus root of x square minus 1 bracket raised to m minus 1. After taking LCM, it will be root of x square minus 1 plus x upon root of x square minus 1. So it becomes m and anything
m upon under root x square minus 1 into y.
Okay, but I will do it this way. Root of x square minus 1 into y1 equal to m into x plus root of x square minus 1 bracket raised to m, which is nothing but my. What is the next step? No, we have already said that we don't require root. Right, so squaring both sides. So you will get x square minus 1 y1 square equal to m square y square. Differentiate again. Karo. X square minus 1 into 2y1 into y2 plus
y1
into
square 2x.
So 2x into y1 square equal to m square 2y y1. Yep. Now what? Cancel 2y1. So you will get x square minus 1 y2 plus x y1 equal to m square y. Shaunak, differentiate it 10 times. X square minus 1, that is u, yn plus 2 plus n into 2x yn plus 1 plus n into n minus 1 upon 2 factorial into 2 yn plus second term plus x y1 to be differentiated n times plus x into yn plus 1 plus n into 1 into yn equal to m square yn. Right? Now collect them and complete it. It will be proved. So now it will be turn by turn, everybody will have to do it, right? I will give you the next set. That was fifth one. Sixth is y equal to sine of log of x square plus 2x plus 1. He says prove that x plus 1 bracket square yn plus 2 plus 2n plus 1 into x plus 1 yn plus 1 plus n square plus 4 yn equal to 0. Y equal to a cos of log x plus b sine of log x. Prove that x square yn plus 2 plus 2n plus 1 x yn plus 1 plus n square plus 1 yn equal to 0.